All right, I just want to throw out about 3 more examples here just to make sure you have some. So, example 1 of 3, we'll start with x squared plus 5x plus 6 plus 9, x squared plus 9x plus 14 times x squared plus 7x plus 10. I don't know if you heard me mention earlier, but factoring patterns are going to be beneficial. Remember, I can't cancel things unless they're being multiplied together. Plus sign, plus sign, plus sign. All these things got plus signs in them, and that just happens on this example. So we have to do some factoring. Now, remember, there's variables down here, so we want stipulations. Rule of thumb, factor first. Stipulations will be easier to find. Again, factor first. Stipulations will be easier to find. So look, trinomial, 2 factors of 6 that add up to be 5, 2, and 3. So some of you will start doing things like this. Nothing wrong with it as long as you're neat and organized. 2 factors add up to be 9. Now, what I would suggest doing is after you rename them in a factored version, do that. Do that. Some of us kind of see all these things and we don't want to get them confused. All right, 2 factors here that add up to be 7. X plus 5, x plus 2. And yes, all of these are nice. I'm not using the AC method. You will in some cases. Please don't get lulled to sleep by this. And 2 factors here, x plus 3 and x plus 5. So, my advice, get your stipulations out of the way now. And it's the denominator we focus on. So what stipulations do we have? Well, it can't be a negative 2. Can't be a 7. I'm sorry, negative 7. Can't be a negative 3. Can't be a negative 5. So you got 4 potentials in this one. Okay, so be it. From the original. Some of you are going to say, well, I cancel these out. It always goes back to the original. So now, canceling. Vertical cancel here, here. Next plus 7, I got nothing. Next plus 3, no more up here, so we have a 1. Diagonal cancel there. We can go vertical cancel here and vertical cancel here, nothing left. So we have our 1. So what's our final answer going to be? We're going to have x plus 2 over x plus 7 with those stipulations. All right, let's try this one. This one will go a little division. So x squared minus 16 over 12y, 36, divided by x squared minus 12x plus 32 over y squared minus 3y minus 18. It is a division problem. Keep, change, flip. Change, flip. Now, some of you are going to do that, then factor. Some of you are going to factor, then do that. Your call on that completely. Your call completely. I'm going to try to combine 2 birds with 1 stone here a little bit. But as I look, difference of 2 squares, factoring pattern. Factors into a sum times a difference. X plus 4. X minus 4. No factoring pattern that I know off the top of my head, except, don't forget your friend GCF. So we can factor 12 out of those. Keep, change, flip. There's the change. There's the keep. And now we're flipping this. So before I do so, I'm going to factor. I need two factors of positive 32 that equal negative 12. That's a negative 8 and a negative 4. Multiplied positive, added that. So that's going to go where though? I'm flipping. So that's going to go down to the x minus 8 and x minus 4. Over here, two factors of negative 18 that equal negative 3. Well, that's going to be a negative 6 and a positive 3. Again, flipped. So y minus 6, y plus 3. So let's now do our stipulations. Y can't be negative 3. Can't be 8, can't be 4. There's our stipulations. All right, now, can we cancel anything? Let's see. Vertically, nothing, nothing. Let's look diagonally. Here's an x minus 4. Here's an x minus 4. Diagonally, y plus 3, y plus 3. What are we left with? And again, don't multiply the quantities. Get an x plus 4 from the first numerator. Get a y minus 6 from the second numerator. Over 12 is still here. And x minus 8. So there is our final answer. All right, one more example for this lesson. So this example will then give us something that looks like this. B minus A over A, all divided by A minus B over 3. So, looking at our problem before we freak out, we have all right, sorry about that, I hit the wrong button. We got a fraction and a fraction. Remember, all fractions are division problems. This means divide. Now, some people might want to jump to the stipulations right now. What's going to make this 0 if both those are equal? So our stipulation in this problem is A and B cannot be equal to each other. Okay. So what am I going to do with a fraction and fraction? Written vertically. Write it horizontally. So here's what we got. Numerator. B minus A over A. Wrong one, Brett. Divided by A minus B over 3. Our phrase, keep, change, flip. So, B minus A over 3. Change it, flip it. 3 over A minus B. Now, we look, man, those look real similar, but they're not quite, because it's positive B, negative B. Negative A, positive A. They are complete opposites in sign. So when you notice opposites, complete opposites, think a negative 1 is going to get factored out. You can do it at the bottom, you can do it at the top. I'm going to do it to the top one just because I like to see things in alphabetical order. So up here I'm going to factor out a negative 1, meaning what? Change of signs. So I get A plus B there. over 3 times 3 over A minus B. Well, look what happens. Nothing. I didn't get the complete opposite that I wanted. I didn't get the complete opposite that I wanted. So, what do? Well, that's what happens sometimes. You might factor these things out and you think you got an idea like this, and then they don't cancel out. So then what? We don't panic. You just, okay, I tried, didn't happen, so I write out what I can. Now, we know those can cancel, so we got a little bit out of it, but it might happen. So don't be discouraged when it does. So what am I going to do? I can leave it like this. Some of you might rewrite it like this. But the big point I want to get across to you is those A's can't cancel. Neither can those B's. I didn't get that plus sign that I wanted there. Did not get it. So it's completely fine to do this. Somebody's going to say, well, if I factor a negative out of here, then it gives you a negative A. Or we can write what we had. B minus A minus B. We tried. We almost had it, but not quite. And again, what's our stipulation? A cannot equal B.